In this problem, they give us a finite series. As n goes from 1 to a, we're adding up the terms given by b. And they want us to find a, and they want us to find b. Now, the terms that they give us begin with 5 and goes all the way to 31. And we're adding each of the terms in this series. Now notice as I look at any two subsequent terms, for example 5 and 7, the difference between 5 and 7 is 2. So to get from 5 to 7, I'm going to add 2. To get from 7 to 9, I'm going to add 2. To get from 9 to 11, I can add 2 again. And so it can be assumed that this pattern is going to follow all the way until we get to 31. Now we can go on and try to determine a formula that begins with n equals 1 and goes all the way to some value a, which hopefully we'll find out. That's going to carry us all the way until we get to 31. But it just so happens that this particular type of series is what we call an arithmetic series. An arithmetic series means that there's a common difference between subsequent terms. In this particular case, that common difference will be the number 2. 7 minus 5 is going to give me 2. 9 minus 7 gives me 2. 11 minus 9 gives me 2. So we will say that that common difference, we'll call it D, is equal to 2. With an arithmetic series, there's a formula that allows us to give helps us to find the nth term. The first term of the series is 5, the second term of the series is 7, the third term of the series is 9, the fourth term of the series is 11, and we do not know what term is going to give us the 31. That's what we're going to have to find in order to give us A. But the first thing we need to do before we can even find that is to come up with our formula B that is going to give us the nth term. So, with an arithmetic series, the formula to find the nth term looks like this. You're going to take the first term of this series, and then you're going to add to it d times n minus 1. Again, if you did, I don't expect you to have known this formula. However, you'll just have to use trial and error if you don't know the formula to play with this and figure out, okay, well, what would n have to be in order for me to begin with 5, and then my next term will end up being 7, and then my third term will be 9, and so forth. But since the arithmetic series has a nice, neat little formula, I thought I would introduce it to you. In this particular case, our first term is 5. So our a sub n is going to be equal to a sub 1, which is 5, plus I told you that d is our common difference, which is going to be 2, and then we have n minus 1. I'm going to distribute my 2. So 5 plus 2n minus 2, and if I combine my like terms, I end up with my nth term being 2n plus 3. So b, which we know is going to be a sub n, is equal to 2n plus 3. Well, let's check to see if this works. If it works, that means a sub 1, when n is equal to 1, I should get 5. Let's see what happens. 2 times 1 plus 3. That gives me 2 plus 3, which is 5. So that works. a sub 2. That's my second term. I should get 7. Let's see. That's going to be 2 times 2 plus 3 equals 4 plus 3, which is 7. Let's do the third term. Third term is going to be 2 times 3 plus 3. That gives me 6 plus 3, which is 9. And as you can see, it's working. I'll leave the fourth term for you to try on your own. But now we know that this is going to give us, this formula gives us b. We now need to determine what capital A is. Well, remember, we need to figure out, well, what value is going to help us to get that 31? A sub what? Well, 2 times 14 plus 3 gives us 28 plus 3, which is 31. So the term that is going to give us the number, or the 14th term, is going to be equal to 31. So B is equal to 2n plus 3. Capital A is equal to 14.